Hello and welcome to my video, Dynamics, where we're looking at more advanced example questions here. And so if you haven't yet watched my Dynamics intro video, I suggest you watch that as we talk about what forces are and how to generally solve for them, so F equals ma, as well as these steps to solving a couple of the more basic examples. We're going to get into a couple more complicated ones today, and in our next unit we'll start looking at angled ones. And so, for example, right now we don't actually do this step because we're not doing the angles, but that's what we're going to add in 2D vectors. So at this point it's just these steps, and I'm going to try to do them in the same colors so that you can see what step is happening at what point. So let's go ahead and try this first question out. Mr. Traeger slams on the brakes, sliding on the icy roads, winter roads. The coefficient of kinetic friction was only 0.1. Assuming the net acceleration was 3 meters per second squared, what was the mass of the car? Okay, so let's go ahead and try to solve for this question. So first of all, we need to create a free body diagram. So you can draw a nice picture, or I recommend just drawing a rectangle and saying, hey, this rectangle is my car. My car was moving in a direction, but actually, even though it was moving, I'm just going to go like this, it's moving this way, okay? The force of friction is actually the other way, okay? Interesting to note. There's also still the force of gravity and the normal force going up. This is important to include. Actually, I'm going to just draw this a little bit better. Force of gravity and normal force. This is important to include, even though our vertical are going to cancel, because of what? Well, because the force of friction, so this is mg, and the force of friction equals mu times Fn. This was stated in our last video as well. Mu times Fn. So that is our formula for force of friction. So we're going to need to find normal force first. And so this is actually, potentially, we could use this to help us out. Most of the time, Fn just equals mg, the same as Fg. Not always, but in this case it does. So let's go ahead and prove it using our next step. So F net, I'll say vertical, equals ma. Well, first of all, is it actually accelerating in the vertical direction at all? No. Is it like accelerating through the floor or flying in the air? No. So then this is just 0 equals, and then all the forces added together. Well, in this case, it's Fg minus Fn. Okay, and just looking at this part now, we can rearrange to solve. So it is Fn equals Fg, and that can tell you also that Fn equals mg, because Fg equals mg. Okay, that's the vertical direction. What about the horizontal? F net h equals ma. Now, is our acceleration 0? No, actually the acceleration is 3 meters per second given in the question. So we cannot say it's 0, but the only force acting upon it is the force of friction. Okay, so with that in mind, we're solving for the mass of the car. So we're using opposite operators to get the unknown on top and by itself. Okay, so divide by a on both sides, so we get F divided by a. So it was multiplying by a, now it's dividing by a to move it over. Okay, and then what we have to do is go, hey, Ff equals mu times Fn. So that's good. But actually we can take a step further and say, hey, that is, another way to write that is mu times mg, because we know that Fn is mg in this case. Not always, but in this case and a lot of others, that is the case. And unfortunately, mass is going to cancel. So I did not think about this question very well. So probably, yeah, I should have changed the question. I'm just going to change it right now in such a way that it should work. So I'm just going to say, what is the acceleration of the car? Okay, I didn't do a great job of looking at this question ahead of time, apparently. So anyways, this would be, so I'm going to say this is MA and this is mu Fn. Okay, and then what we can say is this is MA and this is mu mg. And then we can say, hey, we want to solve for A, so we're going to divide by m on both sides. So it is mu times g. Okay, and so now what we're going to do is substitute in the known values. So mu is 0.1. There are no units for mu. Gravity is 9.81 meters per second squared. This is the acceleration due to gravity. And so now what we're going to do is plug this into our calculator and solve for an answer. So just wait a second as I bring the calculator across. So 0.1 times by 9.81, and we get 0.981 meters per second squared. So not a really great acceleration, and actually our coefficient of friction is just 1, so I think we could probably say that's 1 meter per second squared. That's probably, we should probably have more digits there, but hey, it's one sig dig, so there it is. Okay, let's do another example question here. There it is, my mouse. Okay, so here are two pulley examples. We're going to do the first one here first, and then we'll do the second one. A mass of 1.5 kilograms is being pulled across the surface by a string attached to another mass. Through a pulley as shown below. What is the mass of the hanging object if the acceleration of mass 1 is that, 3 meters per second squared? I'm going to say 3.0 so that we have more sig digs, assuming no friction. If you can do this question ahead of time, go ahead and try it out. Pause the video, try it, and see if you get the same result as me. All right, so let's take a look at this situation. There are a bunch of forces to draw. If the picture's done for you, may as well use it to help you do your free body diagram. So that's Fg, this is Fn. Over here we've got a force of friction holding back from the motion, and here we've got Ft, force of tension. On this mass we've got the force of tension. On this mass we've got the force of gravity. Okay, now it's really important that you note that this is Fg1 and this is Fg2, i.e. they're coming from different masses, so M2g and this is M1g. That's important to note, okay? Okay, and it's important to note that both forces of tension are actually equal to each other. So be aware of that. Okay, so let's take a look at this situation. Oh, that was loud. Let's take a look at this situation and start with our mass 2 here. With mass 2, we know that Fnet equals MA, and we know the A value because if mass 1 is accelerated by that much, so is mass 2. Okay, and so this is Fg2 minus Ft. Okay, I should have tried this question ahead, but that's all right. I'm sure this will be great. So now let's take a look at the first mass, where we've got F net equals ma. We know the acceleration, and we know that it's ft minus ff. Oh, sorry, assuming no friction. Oh, I didn't see that. Okay, assuming no friction. So ft is ma. Okay, well, okay, that's all right. So what we can do now is, oh yeah, that'll work. Okay, so what we can do now is we can say, hey, well, ft equals the ma from the fnet, and we know that, so actually, let's write this out slightly differently. This is m1a, because we're looking at the first mass. This is m1a. So that means that ft over here is also m1a, whereas this one is m2a. So m2a equals m2g minus m1a. So what I've done here is I've just replaced fg2 and ft. Now let's see if I can make this work here. So now let's move. We want to get all of our mass 2's to one side. So m2a minus m2g equals negative m1a. So I've just subtracted by the m2g term on both sides. Okay, now what I can do is actually factor out m2. This is a really interesting thing here. We can do this because of GCF from Math 10. Okay, so factored out the m2, and now I need to divide by a minus g. So m2 equals negative m1a over a minus g. Okay, so that's what that looks like. Now let's go ahead and put the values in. So negative, probably because our acceleration, yeah, so those two negatives, you could flip this in two different ways and make it work, but anyways, we'll write it the way we have it. So 1.5 kilograms times A, which is 3.0 meters per second squared. And then we've got A, which is 3.0 meters per second squared, minus 9.81 meters per second squared. And so now we just have to try this out in our calculator. So we've got negative 1.5 times by 3.0 over 3 minus 9.81. So our second mass is 0.66079 kilograms. Oh, I should have done that in orange. 0.66079 kilograms. And because of sig digs, that's 2 sig digs, so 0.66 kilograms. All right. Yes, this question does work. I was worried that it was going to be like the last one where we had to change the wording here. But no, it's all good. Always just go one step at a time. If you're not sure if it's going to work, try it out. One step at a time, it should work out. Okay, and because I solved these in my head, but I didn't quite actually try them by hand. And sometimes if you do it in your head, you just rush and don't do it properly. Okay, let's take a look at this example here. A mass of 56 kilograms is hanging in a box attached to a pulley, which is attached to another mass in a pail as shown below. If the system does not have friction and is at rest, and another part is the mass of the string does not matter, and is at rest, what is the mass of the second mass in the pail? Okay, so there's some complicated things going on, but first let's take a look at our first mass. So our first mass is 56 kilograms, 56 kilograms hanging in the box, and it's got the force of gravity down, so I'm going to call it G1, and then we've got two things. We've got the force of tension up, and we've got another force of tension up. Okay, and because this rope is never broken, okay, because of that, it actually they're equal. So there's two forces here, two forces of tension that are equal to each other. All right. So the reason for that is because this is pulling off the wall and this is pulling upwards on the other side of the rope. So it's kind of a weird thing, but this works. Assuming no friction, this works. Okay, that's our first mass. The second mass is a little bit easier, M2, and there is the force of gravity 2, and there is the force of tension. Again, this force of tension is connected via rope to that force of tension, so those are equal. So actually, all of the FTs in this example are equal. That's really important because it allows us to do some stuff. So first of all, let's do this. F net equals MA. Well, if we know A is 0 because it is at rest, not moving, that means F net equals 0, and it equals all the forces added together. So FG1 minus minus 2FT, or FT plus FT is fine. So whichever way you'd like. So because of this part, we can rearrange it, which is really nice. I'll get to that in a moment. So our second mass, let's do the same thing, but for a second mass, MA, well, is it moving? No. So it's 0 equals FG2 minus FT. All right, so now let's rearrange this, this part here and the other box part, and solve for T in both cases, or rearrange it so that T is on one side in both cases, and I'll show you why in a second, or at least in the one. Actually, let's just do it over here. So FT, I'm going to add it to both sides, and we've got FG2 here. And I can go one step further and say, well, this is M2G. So now I can use that value back in here. So first of all, we'll move the FT over, the 2FT over, like this. Okay, then we'll plug in this value in here, and the other value in the first one. Okay, and then we're going to move stuff over and solve for M2. Okay, and so we'll have M1G over 2G. Okay, and you'll notice that G's cancel, and so we're left with M1 over 2. Okay, and actually we're not going to have to write this in our calculator because this can be done by hand. 28 kilograms. And again, I should have written this part in green and this part in orange. All right. So again, tension is really nice because you can follow along the rope and it will always be the same along any length of the rope. That's the benefit of tension. Okay, so yeah, I hope that this video helps you understand the basics of dynamics or some more complicated examples of it. And once you get into 2D vectors, which is going to be on our next video, it gets even more complicated with inclined planes and well, angles of all sorts, where two people are pushing at different angles, that sort of thing. So I hope this video helps, and good luck.